All right, here we're going to start Huffman code, and in this case, let's take a look at perhaps something that's already been built. This would not be a Huffman tree. This would just be a regular tree that's built from a specific coding system. The way we look at labeling a tree is everything to the left is a 0 and everything to the right is a 1. So every time we hit a branch, on the left side it's going to be 0 and on the right side it's going to be 1. So I'm going to go ahead and fill this in 0, 1, 0, 1, 0, 1, 0, 1, 0, 1, 0. And in this way, we can see that all of these particular codes are essentially weighted the same. And I can come up with, so A, E, I, S, T, P, N. I can go ahead and determine what the codes are based on their location. So let's go ahead and follow where they are. So I'm always starting from this start point. So let's say I want to find A. To get to A, I have to go through 0, 0, and 0. So the code for A would be 0, 0, 0. Then to get to E, I would have to go 0, 0, 1. So the code for E would be 0, 0, 1. The code for I, right here, would be 0, 1, 0. 0, 1, 0. So you can see how each of these has a specific place that it's located. So S would be 0, 1, 1. So 0, 1, 1. T is going to be 1, 0, 0. 1, 0, 0. P would be 1, 0, 1. So 101. And then our last one, N, would be 1, 1, 0. 1, 1, 0. So you'll notice that all of these codes have the exact same bit length, so they're 3 characters. And so that's not going to help us much when it comes time to compressing the data. So one of the ways that they looked at changing things was to use what's called the Huffman code. And that's based on the frequencies and how often something pops up. It can also be described as probabilities. So I'm going to do frequencies first, and then we'll do the example with the probabilities. So here would be my original tree, and then now we're going to look at a Huffman tree. So the first thing I do is take a look at my different characters. And each of these characters has a high number or a low number or somewhere in between. And so I'm going to start with the lowest number. And I'm just going to go ahead and take and rank all these frequencies from lowest to highest. So lowest to highest. Okay, so my lowest is N, my next lowest is S, and then I have T, and then I have A, and then I've got I, and then P, and then F. All right, so that is going from lowest to highest. So I'm going to start with my tree. I start with the lowest 2. So 1 is going to go down first. So 1 is the letter N, and it's the value of 1. So I'm going to put 1, and that's N. And so I've got that one done. And then my next highest is T. No, sorry. My next highest is S, and that's 3. So 3, and that's S. So I'm going to put both of those together, and when I add them up, I get the number 4. Now 4 is significant because I want to take a look at my highest number. Is that still below 15? Yes, it is, so I'm going to continue to build. So 1 and 2 is off the docket. Now I'm going to add T, which is 4. So T is a 4, and those two are going to come together, and I'm going to get the value of 8. And I look, and sure enough, 8 is still less than 15, so I'm going to keep going. My next highest, I've got 1, 2, 3. Now I'm going to go 4, so that's 10. So A, 10, 10, and that's A. And then when I put both of those together, I get 18. Now I'm at the spot where 18 is actually higher then 15, right? That was my, that was the highest that I wanted to go. So now I'm going to have to create what's called a subtree, so another subtree, using the next two. So I've used 1, 2, 3, 4. Now I need to put 5 and 6. So that's I and P, or 12 and 13. So 12 and 13, that's I and P. And both of those are going to add up to give me 26. Okay? Now here's where it's kind of weird. 26 is also higher than 15. Well, I have two subtrees and I need to bring them together. So the goal is to have my last one come in under the smallest number. So between 26 and 18, 18 is the smallest number. So I'm going to put 15, which is the value for E. And both of those are going to come up to a value of, let's see here, 33, 33, right? And then 26 and 33 are going to come up to 59. Check my numbers on that, okay, just to be sure. And I've got 15 plus 18, yep, 33 plus 26 is 59. All right, so that is my Huffman tree based on my frequencies. So what I'm going to do from here is the same thing that I did before. To the left is a 0, to the right is a 1. To the left is a 0, to the right is a 1. To the left is a 0, to the right is a 1. To the left is a 0, to the right is a 1. And I finish out that tree. So then, based on this, I can actually come up with the code for it. So let's look over here on the side. Let's do I. So I is 0, 0. That's I. So I is 0, 0. Then let's look at P. P is 0 and 1. So P, 0, 1. Then I'm going to look at E. E is 1, 0. So E is 1, 0. Then I look at A is 1, 1, 0. So A is 1, 1, 0. And then I look at T. T is 1, 1, 1, 0. So 1, 1, 1, 0. N is 1, 1, 1, 1, 0. 1, 1, 1, 1, 0. And then S is going to be 1, 1, 1, 1, 1. So 5 ones. 1, 1, 1, 1, 1. Okay? So that's what a Huffman tree looks like. So let's go ahead and take a look at your example that we have in your notes. It's example 6. So I'm going to look at the same thing. I'm going to make a chart, right? So I have A, B, C, D, and E. So A, make my chart here. Get my values. Let's see. Get that. There we go. All right, so A is 0.125. B is 0.051, C is 0.215, D is 0.173, and E is 0.210, and then F, add that, is 0.226. All right, so I'm going to go ahead and rate these from smallest to largest. So my smallest one is B. My next largest one is A, and then D, and then E, and then C, and then F. Okay, so those are my rankings. And so I'm going to go ahead and start with 1 and 2, right? So my first two are going to be 0.051, which is B, and 0.125, which is A. Those two are going to come together, and I'm going to add those. Okay, when I add A plus B, I get 0.176. Is that smaller than my biggest number? Absolutely, so I'm going to keep going. So 1 and 2 are done. I'm going to go with 3. So 3 is going to go to the side here, and that's 0.173. And both of those are going to come up to give me 0.349. 0.349. All right. So here's where I've reached above that limit. So I kind of have to stop there, and I have to create a new subgroup. And let's make sure I have the letter here. This was letter D. All right. So then my next subgroup is going to be the next two, which is going to be 4. My fourth one, 210, that's going to be the letter E. And then my fifth one, which is 0.215, and that was the letter C. And those two are going to get connected. And when I add those together, I get 0.425. Okay. Now, I have everything listed except for this last one. 0.425 is also larger than that 0.226. And so between these two, I have to figure out which one is the lowest of the two, which is going to be that 0.349. So I'm going to add it there. So F 0.226. Both those are going to form a node, and then both of these are going to come up. Okay. All right, and from here, I'm just going to go ahead and label my left and right. So left is 0, right is 1. Left is 0, right is 1. Left is 0, right's 1, 0, 1, 0, 1. So from here, I can go ahead and come up with my, my codes. So let's go ahead and write them down. A, B, C, D, E, F. So A is going to be 1, 1, 1, 1. B is going to be 1, 1, 1, 0. 1, 1, 1, 0. C, which is right here, is going to be 0, 1. So 0, 1. D is right here, so it's going to be 1, 1, 0. E is right here, that's going to be 0, 0. So E is 0, 0. F is 0 or 1, 0. So F is 1, 0. So that would be my coding for A through F based on my Huffman code of to compress. All right, so consider the Huffman code created using the code words from the previous example. Decode the message. So I'm going to pull that in with a picture that's a little bit bigger, just so that I can kind of take a look at it and separate it a little bit. So I don't have a 1, 1, 1. So I can't stop it after that, but I do have a 1, 1, 0. So I'm going to put a line right there, and I have B. Then I go ahead and take a look, and I do not have a 1, 1 or 1, 0, 0. Excuse me, but I do have a 1, 0, and that's going to be F. I don't have I have a 0, 0, so that would be E. I have a 0, 1, that would be C. And then F is 10, so that would be F. Another 10, that's F. And then 01 would be C. And then I have 4 ones in a row, that would give us A. O1 would give us C. OO would give us E. And then 10 would give us F. So that's how we would go ahead and decode. So you really just have to kind of look and see where they fit in and get those done. Okay, and then in example 8, decode the binary string that uses the same one. So you're going to take some time and go ahead and go through that one. Again, we have 00, we have 110, we have 4 ones, we have a 00, and we have a 10 and an 01. So that's going to give me E, and then D, let's make sure, and then triple ones is A, and then 00 is E, and then 10 is going to be F, and then 01 is going to be C. So you can go ahead and decode both of them based on, and this decoding is this one right here. Okay? Hopefully that helps with your Huffman.